Alright, let's see if the lights gets better now. The lighting is better now. Yesterday we had a code alert, and this is next higher rating. Exception number 1, section 43052C1. Use a next higher standard size rating or possible setting when values for the branch circuit, short circuit, and ground fault protection device do not correspond to the standard size or ratings of fuse, non-adjustable circuit breakers, thermal protective devices, settings, or adjustable circuit breakers. Okay, so we did the assignment yesterday, and I noticed that y'all, once it did, did take it up. All right, I want you to remember that because we're going to use it again here on branch circuits with more than one motors or a feeder for several motors. Okay, right now I only have one. I only have one motor here, so I have the wire, and here's my 3-pole breaker. Okay, this I have a 2 horsepower motor and a 1 horsepower motor. My power available is 120/208, 3-phase. The breaker is an inverse. So here's my breaker, and here's my black, red, blue come across. Here's my motor starter, and then here's my contacts. Here's my thermal overloads. Okay, so this is the way a diagram would look to always remember. So, and here I put down the service factor. I haven't done the math, but when I send you your assignment, find me the overloads. Okay, find me the thermal overloads. I just want to keep the thing and learning, and then so hopefully it sticks. All right. Branch circuits with more than one motor. Each motor must have overcurrent protection. So there would be a breaker here. Sorry. There would be a breaker here. This is a motor starter. I didn't put it in, but it would be one in here, or a fuse, or whatever it may be. And then we can find the individual fuse. I did it here. Where am I? Up here. So for this one I would have a 20 amp, and looking at this one I would have a 15 amp. Okay, that's pretty easy to figure out, but we'll get back to that in a bit. Section 43053A protection does not exceed controller for motors with less than 1 horsepower and full load ratings of 6 amps. Section 43053B, multiple motors allowed if overcurrent protection is less than the smallest rating of all motors. And section 43053C, group installation on a single branch circuit. So this is what we got. And it says feeder for several motors, overcurrent protection device for each motor, group overload protection for a common feeder. For additional loads, overcurrent protection no greater than the largest rating plus the full load current. Okay, something else. We'll worry about that another day. Okay, so right now we're multiple motors. I'm going to send you 2 assignments. One assignment is going to have 2 motors, and the other one's going to have 3 motors. Okay, so same thing. You're basically going to do the same thing. Again, don't worry about sizing these. You can if you want to. So here, let's say I'm using a time delay fuse. For most parts, when you're using a motor, anytime I've used fuses, I've always been time delay. They can handle a little bit better than a non-time delay. So here, if I got it 7.5 times 1.75, it's going to be less than 50. It's going to be around 15. Let me put my calculator. Yeah, 13.12. So that would mean it's a 15 amp. And here, obviously, if this is 7.5 and this is 4.6, our number would be less. So it would be 15 amp uses on both of them. All right, go back here. I got a 2 horsepower motor. My voltage is 120. It's a 208 3-phase. My full load amps. This is full load amps, or full load actual. That's a motor. So the actual, the actual. Or okay, so 5.7. This is off the main plate, and service factor 1.15. And my other motor is a 1 horsepower 3.8 FLA. Okay, And if you notice up here, I got FLC. Okay, up here I got FLC. So it's 4.6 FLC, 7.5 FLC, the C, current or the code. Here I'm basically amps and here it's current, but this would be actual, the actual motor, and this would be code, the code book. These came out of 430, 248, 430, 250, I'm sorry. Both of them did because they're both three-phase. Both of them did because they're both three-phase. Right? So again, when I send it to you, I'll give you a scenario, and because some of them are dual voltage motors, so I just want to make sure. Okay? I don't want nobody getting confused. All right. So what the code says is for the wire size, get the largest motor multiplied by 125%. Add all other motors. Add all other motors. So that motor's 7.5 times 125%, 9.375, 4.6, and then I get that 4.6 from over here. I added, and I'm up to 13.97. So all I need is a 14 gauge wire. All I need is a 14 gauge wire. Okay? And then my breaker. As I said, breaker inverse. So I get my largest motor. So you're always using your largest motor first, then adding all other motors. Okay, so I get my largest motor, 7.5. I multiply by 250%, and this comes off of table 430.52. 430.52. I'm using an inverse time breaker, 250%, 7.5 plus 2 equals 18.75. What's my next breaker size? Looking at this. That first motor, you take it up. So I go from 18.75 to a 20 amp. Then I add all other motors. Then I add all other motors. So I add that 4.6, it comes out to 24.6. My breaker would be a 20 amp. Okay, you only go up once. You only go up once. Okay, when you add everything else, if you're at a in between, you come back down. Okay, so once you add all other motors, if this does not end at a standard size from 240.6, from Article 240.6, which is standard size breakers and fuses, if it doesn't end on one, then you go back down. So I'm not at 25. I'm close to it, but I'm not at 25. So I have to go down to 20. Okay, if I put that 20 in and 20 doesn't hold, and then yes, I'll change it to 25. But the code says you come down. Okay, the code says go down, so it would be a 20 amp breaker. Pretty easy. It's not hard. And then the next part, oh, I gotta go back a little bit. So this is the multiple motors. It has the part that I skipped is conductor supplying motors and other loads. I almost forget. Conductors and motor loads. So it's capacity at 125%. Full load current of the largest motor. Full load current of other motors. And amp rating of any other loads. So again, going back and look at this question. Let's say I had a 4 amp heater load. I had a 400 watt, let's say I had a 500 watt heating element. Okay, so I just get my little here. So 500 divided by 208 divided by 1.732 equals 1.4 amps. 1.4 amps. All I would do is add it here. So if I did have that heating element and it took this above the 25 amps, now we can put a 25 amp breaker. So all this is saying is capacity, 125%, your largest motor, add all other motors and the amp rating of any other load. So if you got a heating element, the light bulb, or whatever it may be, all other loads, just add them in after you got your largest section. Section 430.24. And it says conductor supplying multiple and combination load equipment. Capacity to supply the minimal capacity listed on the equipment nameplate. So the more important is the equipment part, and then you just add all other equipment. These are two different things, and they're talking about two different things, but they only have, it's basically the same thing. So if you have motors, get the largest motor, multiply by 125%, add all your other loads. So if you have motors, whatever that motor is, if you have some type of other loads, lights, heating elements, whatever it may be, add them in. Once you get there, that's how you size your wire. Same thing with a breaker. Get your largest motor, largest current motor, not the largest horsepower motor, is the largest current motor. We had one where we had to size it, and we had 3 motors, well, it was a total of 4 motors. 3 of the motors were 1 horsepower at 240 volts or 230 volts. The Pi voltage was 240. But so we had 3 motors that were single phase 240 volts, and then they had a single motor that was 120 volts. And they wanted to tie it in. They had it all tied into the same system. So when we sized this, guess what went at the beginning? Because the other motors, I think, were 2 horsepower, and the 120 volt motor was like a 3 horsepower, or maybe it was a 2 horsepower. I can't remember exactly. But the thing is it was all on one piece of equipment. It was all on one piece of equipment. So if you have to work on the equipment, you want to turn off all the power. You want to turn all the power, so that way there wasn't a single motor staying lit. Okay, but the motor was the largest current motor. The 120 volt one was the largest current motor. So we have to use that one and then add the single phase motors. So always remember is look at your highest current. Okay, so it's not the largest motor again, largest current. And this is the full load current of the largest motor. Again, and then any other loads. I'm not going to do anything where I'm going to add conductors. Okay, so this is the conductors. This is a combination supplying multi and combination load equipment. So again, if you have multiple motors, it's talking about that. And then here's the overcurrent protection for that. Just two things that we just talked about. Motors with other loads and multi-motors. Okay, so the overcurrent protection, overloads not threatening, and brief. Overcurrent protection for device location. We have to have protection at each one, so motor control center. So this is our motor control center. There would be a safety switch up here. Here, let me just kind of do this real quick. So let's say this is my safety switch, and this is where the fuse would be. Okay. So this is where the fuse would be, because this is a disconnect. So let's just like the ones that I have in the back of on the back table at the shop. So this is where it has a safety switch up on top where you put your fuses in, and it has the motor controller down below. Okay, and the combination starter. So it's a combination. It's a motor control center, not a motor control center. The motor control center is a big one. So a safety switch. It's a combination starter. There we go. Combination starters are the ones I have in the back. So it has a fuse and starter inside. Panel servicing motor circuits. So again, if I was sizing this breaker, I would use a breaker. If I got a fuse going over here, then I would have to size that at non-time delay, 300%. Time delay, 175%. Okay. Overcurrent protection, circuit breaker, fuse type, selected by setting. I just went back a little bit, and then here's the code alert where I was talking about you go up to the next highest up on your first largest motor, and then you just add all others. Again, once we get to this point, we don't go up because we already went up here. So we would have to go back down. So we're not at 25, so we'd have to go back down and put a 20 amp breaker. This is where I was talking about the branch circuit, more than one motor. And feeder for several motors, overcurrent protection at each motor. Group overload protection for a common feeder. So here, let's say this is our feeder coming across, so we have a protection here for the common, and then each one would be individually protected. For additional loads, overcurrent protection no greater than the largest rating plus the full load current. So what is it talking about? I got that 400 watt, that 500 watt heating element. Okay, well, As long as it doesn't exceed this, you're okay. Power factor, that's a different video. We'll get back into that one. But again, this is not very hard. Just checking the time. This is not very hard. Okay, as you can see, I drew a picture and I did the math. So I'll send them to you. Again, I'll put this example, the same example, I'll put it on a sheet of paper and I'll pass it out, and then I'll just make some notes to where I found things. So again, when I send the example tonight, later on today, when I send the classwork, because I still have to type it up, I still have to type this up, and still have to type the homework up because I haven't done the assignment. As soon as I get that in, I'll get it all out to y'all. You all have a good weekend. This is due tomorrow. Okay, by tomorrow night, please, by tomorrow night. If you have questions, ask me today. I'll try to answer them. And then I'll see you all. I'm going to send another Zoom for Monday. So we can get together in case there's questions on anything. You can ask them. Alrighty? You all have a good weekend. I'll talk to you all Monday. Oops, this doesn't turn it off.